We'll jump straight in. So the idea of developers running free in your cloud environment can be pretty scary. And this is a challenge that a lot of our customers face today. So these can be customers running regulated workloads, so such as federal government agencies, to not-for-profits, to even big banks. So how do we move fast and stay secure? So today we'll actually use a real customer example. The customer will remain anonymous for the talk, the whole talk. However, we will use their example and we will put their customer journey forward because they've actually been able to give their developers unencumbered access to their cloud environments while simultaneously their security teams were able to put the guardrails in place to enable their developers to move fast and stay secure at the same time. So we'll take you through their journey. We'll show you what guardrails that they've put in action in terms of the technology as well as culture. And of course, we've got a bunch of reference material at the start, so you can actually get started on your continuous assurance journey today. So for the remainder of this talk, Sara and I will actually take personas of this anonymous organization. I will be a dev lead, and I use AWS to build applications and deliver value to our customers.
And I'm a security architect on our organization's security team. We develop the policies by which our organization needs to operate by, and we also make recommendations around the security controls that need to be implemented in our organization.
So as a dev lead, this is the current application that I'm working with. This is a microservices application for all of our transactions, APIs. So as you can see, I've got Amazon API Gateway to publish all the transactions APIs. I've got AWS Lambda as my serverless compute to run all the application logic. And I've got Amazon DynamoDB as the serverless database to keep my application state. For our organization and our organization's regulatory requirements, I've got all of this running in a VPC. Of course, for your organization, it could be very different, but this is the architecture that I'm working with at the moment. For all of my resources as well, I have IAM roles to give it the right permissions and privileges for the services to communicate. So I'm going to take you through my initial experience. As a developer, I've got all of this laid out as infrastructure as code in CloudFormation, and I'm going to go ahead and deploy this in my production environment as part of the application deployment. And this is basically what I see when I try to deploy it. CloudFormation, going through all the deployments, but I have an explicit deny when I try to create IAM roles. I am completely blocked from creating any further resource. I have to now raise a request with security to allow me to create the roles so that I can do the rest of my deployment during the production change. What a great experience. Thank you, security.
Wow. Thanks to the change window that security forced our development team to abide by, this change actually happened at 10 p.m. and I didn't receive the email until I got in the next morning. As a result, our developers actually had to renegotiate another change window to do their build. And it was a really important build for our organization. Security is once again seen as a blocker to innovation. So clearly there needed to be a better way for our organization to approach security. Today, we're going to take you through the journey that our organization undertook to go from a situation where security, myself, is seen as a blocker, not allowing our organization to innovate, to one that works collaboratively with our developers and operates in a secure manner. So our journey actually started by undertaking a few realizations. The first one that we had realized was that our security had actually developed really robust security policies. We had implemented controls, but I hadn't thought about one customer in my deployment, and that was our developers. So what we undertook after understanding that our controls did not complement our developers was that we actually met with them, got an understanding of the AWS services that they were using, when they were using them, and how they were using them to work out a better way to implement our controls. So this understanding started off with me meeting with our developers, such as Raisa, and starting to build a service catalogue of all of the services. We also got an understanding through that of the controls that are associated with those services and complementary services that were available to us in our AWS catalogue to make sure that we're appropriately protected. We also, through gaining that understanding, understood ways by which we can monitor our developers to make sure that they're operating within the security guidelines that we wanted, also be able to detect anomalous behaviour, and also use monitoring as a capability to better understand our developers' needs. Something that you could do in terms of having an understanding of the services that are available is to map it to something such as the NIST security life cycle. So when we had an understanding of the services that our developers were using, we mapped it against the life cycle to see where we've got coverage. For those in the room here that are probably working with government workloads, another opportunity that you might use is something like the ASD's Essential 8 to map our services against, or even the documentation we have for our protected certification. The next realisation was our culture. Now, the controls that we had in place really didn't promote the sort of culture that our organisation wanted. We had a situation where Raisa had to come to me to implement security controls and give access. It was seen as my role solely. Security wasn't everybody's job, and I definitely don't have enough staff in my team to be able to do all the security work that needs to be done. So we started thinking about those services that we had a look at and started to find ways that we can leverage AWS services and controls to actually reinforce the culture that we wanted. We wanted our developers to be able to move fast but still stay within the compliance requirements that we needed to do. I'm only a small team, so I want to make sure that I'm not actually got someone coming through to me and constantly having to make really, really massive changes. I wanted to find a way to standardize it as much as possible and make small iterative changes. And at the same time, I want it automated, I want people removed from it, I want to ensure consistency and reliability every single time controls are deployed. So the way that we did that is using that understanding of the AWS services that are available, we started thinking about, for every single account that we're going to be deploying in our environment, what are those non-negotiable controls that we need to be deploying to every account? And they're the ones that we're going to roll out every single time an account's deployed. We also use the understanding of the AWS services that our developers might be using and thinking about when do we deploy controls when they make an API call to those controls, to those services. And then at the very least as well, our application-specific controls. What do we need our applications to do every single time we have a workload go to production, and making sure that we have implemented that level of governance before we go to production. The last realisation, and I've slightly touched on this, is that our technology, we're using AWS services, but we hadn't appropriately aligned it to our actual organisation's needs to make sure that we're working with our developers and in promoting the culture that we wanted in our organisation. So to do this, we made sure that all of the preventative controls that we wanted, we had them bootstrapped to every single account for the developers as they're rolled out. We found ways to codify those controls using something like CloudFormation and making sure that that we've got automated delivery of those controls every single time. And again, that context-specific situation. Having services whitelisted that our developers are going to use and making sure that we've got the right guardrails in place when they go to use them. Again, this is a diagram that I provided before, but this is just to provide some context of how you might do it. So at the base level, we might use something like AWS organizations and make sure that we've got logging promoted, we've got appropriate identity and access controls, and the service control policies, those whitelisted services bootstrapped and rolled out in our stack every single time we give an account to a developer. At the next level, they're our context-specific ones. So when Raisa, in her example, makes a decision to make a Lambda call that requires an IAM role to be produced, that API call produces a CloudWatch event, which then promotes a stack of controls to be rolled out to meet the developer's needs. And then AWS config is for our application-specific controls at the top. These are the ones that we're using AWS config. This is what we've done is allowed all of the controls that we've decided that was specific for our compliance requirements. We have them mapped out in our account, make sure that there is visibility and they can see what they need to do before moving to production in the CI/CD pipeline. So, Raisa, what does this look like for our developers now?
So, Sara, funny that you should ask because the experience for developers now is amazing. Let me show you how. So if you can see, this is actually the same microservices application that I'm working with, yeah? So nothing really has changed. I've got API gateway to publish my APIs. I've got Lambda. I've got the Lambda IAM roles that I'll be creating, the DynamoDB tables to keep application state, and of course, all of this running in a VPC. The only things that have changed, as Sara has mentioned, is that we actually have AWS organizations, SCPs, and permission boundaries to provide the preventative controls or the guardrails that I'll be operating in, and of course, AWS config and config rules to do the detection. So let's actually go in and have a look of how it works in practice. So demo, please. Switch to demo. Oh, cool. Okay. I had to record this, pre-record this, because we've got a very short time, but I just want to show you this. So basically, the only thing that I have changed in my CloudFormation template is the permission boundary that's in place, right? So I have literally had to add one liner of the ARN of the permission boundary that I've had to put with my IAM role, and I've done a diff here to show you when I tried to deploy it before versus when I'm trying to deploy it now, of the fact that nothing else has actually changed. So I'm just going to go down and show you that everything else is exactly the same, apart from the permission boundary that I've put on the IAM role. So just scrolling down, as you can see, all of the API gateway resources, Lambda resources, etc. That's all as per the creation. The only thing is the change of permission boundary. So I'm going to go ahead and deploy this. So this is where I've stored in the S3 bucket. I'm just going to create take the stack name and essentially populate the template here. And then I'll choose the subnets and I'll go ahead and acknowledge that I'm creating a bunch of resources and go ahead and deploy. So while this creates, I just want to take you through the permission boundary. This is the permission boundary that's actually on me as the dev lead. So as you can see, I'm allowed to create roles as long as I have this specific permission boundary in place of the roles that I am creating, as I just showed you before. I have all these other accesses and privileges as well to allow me to do my work. So of course, a bunch of IAM ones, as well as denies. And these denies are that I cannot delete any policy, which essentially is a permission boundary, right? So this stops me from deleting permission boundaries that are in the account. And those specific permission boundaries, the ones that's on me and the ones that I need to put on the roles that I create. And if you also notice, I can't actually deny any modification to users or roles, okay? So say that I didn't really like that very much and I wanted to go and change it up a little bit. So I'm going to go ahead and put in IAM star to try and elevate my privileges a little bit and ideally give myself God permissions for IAM. So let me just change this up and try to save this change. Okay, all right. So I don't have the permissions to be able to elevate my privileges. So I really didn't like that, and I wanted to go ahead and delete the policy. So I can't delete it because obviously I have to remove it because it's attached to me. So I'm going to go ahead and remove it from myself. Do you think I'll be able to remove it? No. Cool. So well done, security, very good. So obviously, I'm able to operate within the guardrails that they've put in place. So I can't obviously change any permissions or delete any policies, but hopefully I should be able to create my CloudFormation template. So let me just go ahead and, okay, cool. So there you go. I've been able to create my CloudFormation template without any interactions with security whatsoever. So very good experience so far. Let me just go ahead and see that all the resources have actually created properly. So I'll just go ahead and have a look at the IAM roles for the Lambda. So I'll just open this up. Okay, so there you are, and the permissions boundary has actually been put in place for this specific Lambda role as well. And the permission boundary, of course, gives it the ability to operate with Lambda and DynamoDB permissions as per the microservice application. So that's good. The other thing security has done actually is put a bunch of config rules in place, as Sara was talking about earlier, which is essentially our detection capability. So if you have a look here, you'll see that there are a bunch of baseline controls. So these are the non-negotiables that Sara was talking about earlier. These go into every single AWS account as soon as that account is provisioned, before this account even goes to an application team. So before I even get this application to start provisioning my resources, all of these baseline controls are already in place. So basically the ones that you can see are the non-negotiables. So guard duty, S3, CloudTrail is enabled, IAM policy checks, and then of course, so usually around S3 buckets, IAM roles, guard duties, CloudTrail, or the logging and monitoring, etc. And the other thing that you'll notice is as soon as I deployed all of my resources, so API Gateway, DynamoDB, and Lambda, as Sara was mentioning earlier, on demand, all of API Gateway, DynamoDB, and Lambda controls got deployed. And these only got deployed after I provisioned my resources. And I'll take you through the architecture on that a little bit later. The other thing to note here is security can actually also do remediation on resources. So from the config rules console itself, you are able to set essentially remediation action. So specifically the baseline CloudTrail enabled one, you can essentially do one-click manual or automated deployments from the config rule console itself. So security have also said that all of these rules have to be compliant if I want to go live with my application, which makes sense. So as you can see here, my API Gateway private endpoint policy is non-compliant. So I've actually also received a notification about it on Slack saying that, hey, my resource is non-compliant. Unfortunately, security have actually also given me a snippet that says use this CloudFormation snippet in your CloudFormation template to get yourself to compliance status. So I'm going to go ahead and do that. So I'll make that change. This is the CloudFormation template. And basically, you can see that I've updated that with the condition that this API Gateway has to be in a VPC. I'm going to go ahead and update this template. So of course, it's a new template now, which I've preloaded in an S3 bucket. And I'll just go ahead and create this. And I'll acknowledge and do the deployment. So cool, that's all completed. So let me just go ahead and reevaluate. Okay, so it looks like now I'm back to compliance status. So how easy was that, right? So I know now what's compliant and what's not compliant. And of course, security have given me all the notifications as well for me to go and make those changes myself. So back to slides, thank you.
I'm so excited that I'm not a blocker anymore. For once, the project team will be happy with me. So what did we build? So when security was working with our developers and our organization around our accounts, we made sure that using AWS organizations, we actually had deployed on all of our developers' accounts the permissions boundaries and the service control policies and the identity and access management controls that were needed to operate within the security guidelines that we had set for our accounts. And I'm actually going to dive into the architecture a little bit deeper on that. So here at the very bottom, we have our administrators. On all of their for their accounts, they have the permissions to be able to configure guard duty, have CloudTrail enabled, and have visibility of that coming into their accounts, and even set the AWS config requirements. Our developers, we've actually allowed them with their accounts to be able to deploy the resources that they need. They're able to deploy EC2 instances, Amazon RDS. They're even allowed to put on IAM roles, so long as they put on the permissions boundary that security asks them to put on all of their accounts. And the same applies to our microservices application that Raisa demonstrated before. She was allowed to build all of that, even IAM roles, as long as she puts the permissions boundary on it. So from a policy perspective, we'll dive a little bit deeper into it. So for all of our accounts, our developer accounts, we wanted to make sure that we have monitoring protected. This was to enable us to have visibility of what our developers are doing, as well as being able to detect anomalous activity. So we have an explicit deny on any changes to Security Hub, guard duty, and even turning off CloudTrail logging. We also didn't want our developers to have godlike access or be able to change their access at all. So we actually put a deny on their ability to make any changes to their role or even delete them. But I'm still going to allow them to create IAM roles because they need that to be able to build their workloads. But so long as they have the permissions boundary attached, I'm completely satisfied that they're going to be able to operate within the guardrails that our organisation needs them to operate within. So, Raisa, what did we build from a detect and respond?
So for a detect and respond, of course, we've kept it to the same framework. We've used AWS config and config rules for detection, and we've used Lambda and Systems Manager for the responsive capability. So AWS config and config rules continuously monitors your resources and the resource configurations. You can actually see historical records of your resources, and obviously it's changes over time. And you'll also be able to go back and see the relationships between your resources using AWS config. With AWS config rules, you're able to actually take that one step further and define your organization's requirements in terms of regulatory requirements, compliance, non-compliance requirements, and actually write that as code because config rules are backed by Lambda. So essentially Lambda is running the code for that logic, and see at any point in time what your expected outcome is versus your desired, so the compliance and non-compliance status. And a really great way to get started on writing config rules today, so writing your compliances code, is using the rules development kit. It's actually available open source on GitHub. You can plug it straight into your pipeline as well. So it really allows you to fast track that process to define compliance as code. So feel free to go check that out. But I just want to take you through the multi-account structure for secure deployments. So I'm going to use the same example that I was showing you earlier in the demo. So basically, as a developer, say I create a API gateway resource. So what's the actual flow that's happening that's allowing us to do this cross-account? So or in my application account, I've got the API gateway resources, and as soon as I create that, in the security account, we have a CloudWatch event, an event rule running that actually is triggered as soon as a resource is created. The key thing to notice here is that the security account is completely isolated. It's a tamper-proof environment where all of your security control logic is running, all the Lambda functions associated with the config rules, as well as any CloudWatch events and event rules. And only security who have the right level of permissions and privileges are able to access resources in this account. So no one else, no developers, no one else can essentially tamper with your control code. So as soon as I create a resource, this triggers the event, CloudWatch events and event rule, which actually goes and calls a Lambda function, which deploys using CloudFormation stack sets all of the config rules associated with that resource in that application account. That's how, as soon as I provisioned the CloudFormation template, I got the API Gateway, Lambda, and DynamoDB controls deployed in my account. And this is, so once all of the controls have been deployed, this is the actual detection flow that is followed. So I'll just go back one. So essentially, as a developer, say, I'm still deploying and there are certain configuration changes for my API Gateway resource. This actually triggers the config rules, which essentially calls the Lambda functions in the security accounts. And these Lambda functions goes and evaluates the API Gateway resource using the logic that you've defined in your config rule. And then essentially this Lambda function also again goes and responds back saying, hey, my API Gateway resource is compliant or non-compliant, which you put through with a put evaluations API call to config rule that's running in your account or in the application account. And of course, as I showed you before as well, you can also do automated remediations on that. So if it's a non-compliant, you'll just, from the config rule console, you can directly go ahead and click remediation to do any remediations from the console. And of course, as soon as config gets back compliance or non-compliance status, you're able to trigger notifications directly to Slack, to Teams, to whatever ChatOps tools you're using as well. And that way you can keep your teams notified constantly. So that's detect and respond.
So as you can see, by undertaking this journey, where our organisation has been able to actually enable our developers to continue to build and innovate for our organisation while still operating within the guardrails that our organisation needs us to operate within. Our developers have also been educated through the process. So being able to have a look through the code, they've been able to see what they needed to do differently to be able to do good security practice themselves. And at the same time, we still had that monitoring in place in the background, and security was still enabled to be able to act if it ever needed to, if we were uncomfortable with what was happening. So why is this good? As a security person, I like it a lot. My team is really, really small, and this has really enabled our organisation to be able to operate quickly and not have to be dependent on me for those to give permission to give that access to our developers. It's automated and it's done consistently every single time. I also have visibility of end-to-end of our organisation of how we're meeting our compliance requirements. You saw when we went into the AWS config console that you were able to see what was compliant and non-compliant at all times. And we're also able to, through looking through the code, if ever needed, to be able to give that to an auditor, to be able to provide evidence of what our security is configured like end-to-end. Last of all, codification, and I just touched on that as well. Our developers were able, when they had some concerns, when there was an exception that was provided, they were able to go through the code and work through and understand what they needed to change about it to be able to meet the security team and our organisation's requirements. Also, again, through it being codified, if we wanted to redeploy this on another account, say for another environment, such as redeploy another dev environment or another staging environment, we're able to do that easily because it's codified. And why do you like it, Raisa?
So if you haven't noticed, of course, developers like it for exactly the same reasons. Yeah, it's fully automated. Nowhere in that process did I have to say, hey, Sara, can you let me create some resources? I was able to just go ahead and do that without any human intervention. I have complete visibility. At any point in time, I can get Slack notifications to say if I'm compliant or non-compliant. And on top of that, security have told me how to get my resources to compliant. So I know exactly where I stand at any point in time. And of course, everything is as code. So if, say, I don't understand what I need to do to get to compliance status, I literally can just go and look at the config rule code to understand, okay, this is the logic that's been put in, so this is what I need to do to change my resources to compliant. So, same reasons.
And I hope today that you've learned a lot, and my challenge to you all in this room is to actually get started now. Meet with your product teams and get an understanding of what AWS services that they're using, and start building up a service catalogue of those services and have an understanding of what security controls you have and what complementary security services that you might be able to be implemented to create a governance model that meets your organisation's needs. And as you can see as well, automation has been really simplified with AWS services. Really encourage you to take an automated approach to your security deployment. And we have a number of resources that are available to you to be able to achieve this. We have security and well-architected workshops that allow you to actually experiment with these services with the appropriate guidance of how you can achieve security best practice. And the RDK that Raisa mentioned as well is available at the continuous assurance link at the end. Thank you so much for listening to our organisation's journey today. I really hope you learned something today.
And please don't forget to complete the session survey as well. Thank you very much. We appreciate your feedback.
Thank you.